this swap NA operation will be directly performed on the original GDP subset. So this temp Okay, let's get started. Happy to see you after 2 weeks. The previous week I was traveling, so I hope you learned from Prof. John. And right, correct me if I'm wrong. We should continue from lecture 9, starting roughly with descriptive analytics. So if you have any questions related to the previous exercise, or if there were anything that we did not cover, quickly let me know so we can start a bit earlier from that. Right. So a quick reminder that, let me see. The third assignment will be due by the end of the week. So still have enough time to work on it. But if you haven't started, make sure to send it on time. And also let's take some time to download the slides if you need, and also the Jupyter notebooks, depending on which version of the workbook you want to work with. And also let's try to get, same as before, this is all the same. Let's try to get the package installed. Again, it will depend on which version of the notebook we're using. If it's the offline version, like this. Let me quickly do this. And then we can directly use pip install. If it's the online version and you are using the kernel of Python, things should be fine. It should be automatically installed. But if we are using XPython, then maybe we need conda to install pandas. Try importing them directly. If you see error message, it probably means that, okay, the package is not being installed right now. So you will have to check. Right. When we import packages like this and no error message appears, then we know, okay, we're good to go. So we'll start with the notebook of lecture number 9, descriptive. And let's quickly do this for the online version. If it's Python, the kernel we're using, then I believe we can directly try importing both packages. We introduced both packages so far. One is the plot, the visualization package. The other is pandas, which we'll be using for data analytics. So no error message. But if you are using XPython, version 3.13, then I believe we cannot directly import. Or maybe we can. Well, for the plot, yes. For pandas, no. So you can follow the instructions on the top cell and manually copy paste this single line of code. As I explained quickly 2 weeks ago, this percentage sign is kind of a magic command in the online version, in the online environment. So, well, so if you don't bother, trying out different combinations, just switch to the Python online environment, so everything should work fine. So by the way, while it's installing, let me quickly go through the agenda for the remaining several lectures. So today we are trying to finish maybe lecture, of course, lecture 9 and maybe more than half of lecture 10, which is about functions. Then after today's lecture, we will have 2 remaining lectures. We will spend one, finish everything about Python, then briefly talk about some AI-related large model topics, which will be new this year. And then, depending on how much time we have in the last week, we will try to reserve some time, go through some of the previous year's final exam questions to give you a better understanding of what you may encounter in the final exam. By the way, the schedule has been released, I believe, for our course. The final exam date is on December the 15th. So not too early, not too late. So that should be fine. If you have any questions, let me know. It's most likely to be open book. Well, you can print out notes and if you want. And I promised, for whatever we're learning here in Python, you are not likely to be tested on writing real code. Mostly, all of them should be in the format of multiple choice questions for Python. Yes?
And you have like Excel files for help as well, or no?
Well, that's a good question. What kind of Excel file we're talking about?
So, for example, what we sometimes in Python, sometimes you fill out or not, is that you can prepare kind of like examples for each thing that you have like on your own, and then something to help you with in the final, but maybe that's not valuable.
Okay. Let's make sure you finalize all the preparation before the start of the exam, because that's when we need to block the internet so that you will not access to whatever, whether it's online using the canvas or your thumb drive or whatever. So make sure everything is done before the start. Otherwise, things will get a little bit tricky. Good. Any other questions? Good. Well, for this course, really, I will not worry too much about the final exam because it's only 30%, compared to some other courses, which is like 50, 60%. So if you do relatively well your project and your, assignments, things should be fine. But let me know in case, well, every year we have special cases. In case if you cannot attend the final exam due to very special circumstance, I would expect a very formal waiver before the exam you apply. It was called a mitigation request or something like that. So I hope everything is correctly set up. And let's continue with the descriptive analytics in Python. So far we'll spend a lot of time talking about, making proper references for the different reference systems in the pandas data frames. And then let's talk about working with real data. So one of the first thing that we want to know is when we have a real data file, this is similar to what we have done in Excel already. We have a real data file, for example, like a CSV file. We mentioned this format is a comma separated value. How do we read them to Python? So previously, all our examples are synthetic. So we construct very small data sets to work with. But now, we will deal with the full data set of returns of schooling, which consists of more than 500 observations of people's wages, and their employment, education history, and so on. So the first function we are going to introduce is called read_CSV. So if our data file is in the format of CSV, comma separated values, then the usage or the syntax is, because this is a function from the pandas package, pd.read_CSV, followed by quote unquote the file name. So we can take a look at our data file first. You can also download it from Canvas. It's called wage. We can directly open all the CSV files in Excel. Similar to what we have seen in the Jupyter Notebook, it consists of 5 columns of data. And after loading it, it will print out what the data will look like in the screenshot to the right. So first, we will introduce some quick methods to get an overall understanding of the data set. We will start by the method called head. So once we read in the data file, we can assign a name for it. Sometimes we can call it data. Sometimes because it's a data frame, later we will check the type. Sometimes we call it DF, short for data frame. So one of the commonly used method is called head and tail. By the name, you can probably guess, right? We will just take a quick look of the first several observations or the last several observations by either head or tail. The number you put in are the number of rows, right? If it's head 6, we print out the first 6 rows of the data set. Also, we will briefly talk about, later we will run the code together, we will briefly talk about some of the summary statistics or summary methods. We kind of touched about this topic back in the very first lecture. For example, the summary statistics, including mean, median, the quantiles, making the box plots, then correlations and related stuff. So I have to warn you first, what we show here in the screenshot will be slightly different compared to what we actually run in the code, because the screenshot was from maybe 1 year or 2 years ago. So it's no longer viable. Later we will see. So let's actually try running the code together. Let's go to, I will use the online Jupyter Notebook, for example. Once we have successfully loaded the packages, we can try reading in the files. Pay attention to the folder or the file directory. Here, because I upload, for the online environment, I upload both my Jupyter Notebook and my data file under the same directory, means they are within the same folder. Then in that case, I can directly read in the data file. For example, if your data file is in a different folder, for example, if right now you have a folder called data or you have a folder called folder, then you will have to specify it here. But in most cases, of course, especially during final exam or something, because we are not managing so many different files, it's okay to put them all under the same directory, so it's easier for you to read into. So once we read in the data files, it will show both the first several rows and the second ones, show you the number of rows and number of columns. You see now, currently, if you still remember, now the columns are all as their corresponding labels. And we can quickly check the type of the so-called data object we just defined. It is a data frame. So whatever we learned in the previous lecture, you can directly apply to the current data frame. Only difference is that it's much larger. We have so many different rows. Okay, we have it here. So the head method will show you the first several rows of observations. So if you change the number, for example, 20, it will print out the first 20. If your data has so many different columns, it may not show everything, but still it will give you the first impression or the basic understandings of the data set. Similarly, you can try something like tail. Let me quickly change to any other numbers. Tail of 10 will display the last 10 observations, so coming from backwards. Then we can try some quick summary statistics. The concepts, we talked about all of them already. The mean, which is the average, the median, the standard deviation, variance, and so on. Only thing we need to worry about, if we directly try something according to the slides, like this. So by the way, this /n, sometimes you see that's just a new line when printed out, so you don't have to worry about this. So if we directly try to print out the so-called mean method, which will compute the average value for each data series, like for example, the average wage, the average years of education, we will have an error. Why is that? Because not all the columns we can directly compute the average value, right? It makes sense to compute the average value for the numerical columns like the first 3, or even for the Boolean statements like married. But for gender, this is a text or categorical column. So they are strings. It does not make sense to compute the average for the strings. So what we need to do, if you're interested, you can explore by using the help function. What we can do is to specify within the parenthesis. Instead of leaving it empty, we can write down something like numeric underscore only equal to true. So by default, this is false, means that we are trying to compute the average value for all the data series. But then we will have an error because not all data series are numerical. Then by telling Python that numeric only is true, it will only focus on the columns that are numerical. So let me comment out the second row and only run the first row. So as you can see here, slightly different than compared to the slides. We will only compute the average value for the data series or for the columns that can be evaluated by computing the numerical average. So we can see, okay, on average, across these 500 something observations, the average hourly wage is somewhat $5.9 US. Average education years in school, 12 something. So by the way, this is very interesting. It turns out that for the last column, which is called marriage status, which is a Boolean statement, we can also compute the average value. This is consistent with what we have learned in Excel, right? In Excel, we say, okay, we can treat the Boolean statement or true-false statement as if they are zeros and ones. So how do we interpret it? If we get a number of 0.61, roughly speaking, what does it mean? Can anyone quickly tell me, for the average value of the merit column to be 0.61, what does it mean? Don't be shy, just shout it out. Exactly. Around 61% of merit in the observation. So how exactly do we get this interpretation? We actually show this in the slides. Let me quickly put it out. Forget about the mathematics, but if you think naturally, a Boolean statement will only contain a binary value of either 0 or 1. If you compute the average value across a sequence of zeros and ones, 0 will never contribute to the average. Only the 1 values will contribute. So the average value, actually, the physical representation will be the percentage of the observations that will have the true observation. In other words, the percentage is, roughly speaking, 61% of the observations are merit. So this is how we interpret the average of Boolean statements. And of course, similarly, we can compute the median, but please remember to specify that we are computing, no matter the median, we talk about the numerical values only. So let's continue our exercise in the notebook. For some reason it's not showing here. So if you still recall, median is the middle point. In other words, it's the 50 percentile or the second quantile. Roughly speaking, whenever we have a median, we have roughly 50% of the observations that are above and 50% below. And whenever we compute the summary statistics, the type we can quickly check, they are in the type of the panda series. In other words, we're computing like a column mean or a column median. So it's a panda series, which we have learned already. So similarly, we can compute the standard deviation. Just remember, the numeric only is true. It will compute the standard deviation for, again, all the numerical columns. So the string columns will be left out. And of course, with the standard deviation, we take the square. That will be the variances. So these are all more or less the same because we have learned pretty much all of them back in Excel, and we revisit again in pandas. Similarly, you can measure the so-called maximum and minimum. A slight difference is that here, when you're using maximum and minimum, we do not necessarily need to specify numeric only, because it turns out that we can also compare the values between strings. So by taking the maximum value, because it only makes sense within each data series, so we can see the maximum observations, the largest values numerically. Alternatively, it does not make much of a sense to compare between strings. So Python will actually use a Unicode or alphabetical comparison. So here it does not mean that male is a larger value. That would be politically incorrect. But it represents certain Unicode. If you're interested, you can quickly explore. So for example, Python actually will allow this if we compare two strings. Actually, we can do that, although the meaning may not be very meaningful, right? So you can compare between certain values. One of my favorite examples is something like, I don't know if we tried this before, but yeah. So this does not mean that I'm claiming that our university is better than CHK. In fact, if you quickly try this out, changing the upper and lower cases will completely change the result, because the Unicode for uppercase and lowercase letters are different. So pay attention when you are comparing the non-numerical values, because in many cases they may not represent what you want. It's just a quick note. And of course, instead of focusing on the maximum value across all the data series, you can focus on any specific series, specific panda series. Like we know how to make the reference, right, by calling the label or the column name. So the range of the maximum would be a single number by taking the maximum value for that column only. Then let's talk about some of the useful summarizing methods. For example, counting. Because so far we have talked about the summary methods for the numerical values. So usually what do we do for the categorical values, like the gender? We know the genders here in this data set, we should only have two genders, male or female. So how do we count the frequency or the number of occurrences? We use the method called value count. We do not need to exactly memorize the method names, but telling by the name, we should more or less expect what it does, right? So for this column, gender, which is categorical consists of strings, we use value counts. And roughly speaking, these are the corresponding numbers of occurrences of each possible categorical realization, like male and female. Sometimes instead of the absolute count, 276, we care about the relative proportion, or in other words, percentage. Think of this difference as you are making a bar plot versus a pie chart. So if you want to compute the percentage or the proportion instead of the absolute occurrences, we need to specify something like normalize equal to true. By default, it is false. Normalize actually means that we are normalizing the whole data set as a unit mass of 1 so that we compute the percentages. Let's see. So instead of the absolute number of occurrences, here it only shows the percentage, roughly 52 and 48%. Right? So the name will be changed to proportion. So on a very high level, if you don't bother trying each individual summary method for each individual column, there's a very useful method called describe, which will give you the most comprehensive understanding of the whole data set. So let's see what it does. So we have a data frame called data, then data describe will give us numerical, of course, only for the numerical values, all the required information we have, including the number of observations, which is count, the average value, standard deviation, and the 5-point summary, which is the minimum, the maximum, and the 3 quantiles. And by the way, the 50%, the second quantile, is just the median. Well, this is actually very, very standard because let me assure you, when I write academic journal papers, and if I ever need to deal with a data set, these are the summary statistics in this format. Usually, we need to report to our leaders. So we need to include this kind of information. Then we will very quickly talk about, after this, we will very quickly talk about some of the data visualization methods we already covered. So for the descriptive measures like this, we actually include the very same screenshot and graph back in our lecture 1, if you still remember. And we use the 5-point summary, the minimum, maximum, and the 3 quantiles to characterize the distribution of a certain variable. And if you still remember, if you compute the difference between the 25 percentile, which is the first quantile, and 75 percentile, which is the third quantile, the difference is called the IQR, the quantile range, which we will visualize with the box plot. So later we're trying to quickly plot the box plot and histograms, which we already did in Excel. So for the box plot, well, this is just the same slides in lecture 1. We will have a box, and the box will represent the interquantile range, which is between Q1 and Q3, captures the middle 50% of the observation. The median will be the middle line, and then Q1 minus 1.5 IQR and Q3 plus 1.5 IQR, they will consist of the line segments, which are the so-called common observations we expect. Whatever the extreme values, whether it's below or above, we visualize them as individual plots, and we call them outliers. This is IQR. Hopefully you still remember and be able to interpret the plots. So later we will run the code together to make our box plot in Python. We will use the same package of pyplot, PLT. And you can either choose to, here we are going pretty fast because not so many things that we can change. After specifying the data, for example, here we are visualizing the distribution for the wage column. We can specify whether we want the box plot to be vertical or horizontal. So if vertical is false, then the box plot is horizontal. And we can add the X label, which is the label of the distribution or the data series. And we can change the font size by using the function called X label. So because this is a wage distribution, we briefly talk about this. The wage distribution is extremely skewed, means that, okay, we have so many people that are low income but very few are extremely rich. So all the outliers are to the right side or to the top side. So using box plots is one common way to visualize a specific distribution. What was the other way we learned in Excel, right? If you still remember, it was histogram. We taught at least 3 different ways in Excel to make a histogram. In Python, it is also kind of straightforward. We specify the data series, and we specify the number of beans. And optionally, we can specify the color and the level of transparency, all similar to what we covered in data visualization. And we can manually change the X labels and Y labels. Usually speaking, the frequency, the histograms for the y-axis will represent the frequencies or the number of occurrences. And of course, if you are dealing with a single data series, you can feel free to choose either histogram or box plot or others. If we are dealing with a pair like 2 data series, because we have X and Y, then we make the exactly same scatter plot in Excel, if you still remember, and we add in trend lines, possibly. So if you're interested in exploring the relationship between 2 data series, we're interested here between the hourly wage and the years of education, then scatter plot will be a good option because it will show all the individual pairwise observations on the XY canvas. So this is something we learned before, like DLT.scatter, where we specify X and Y. Here, X is the horizontal axis, which is education in years, and Y is the wage. Also, we can specify the color of the dots, and we can also specify the opacity, which is level of transparency. Actually, in this example, this alpha will help us a lot. Later, we can try changing the different values of alpha to illustrate my point. Then, of course, always feel free to change the X labels and Y labels. And finally, we can use the correlation. We can use the correlation CORR function to construct the correlation table between all the numerical values. We also did this in Excel. Excel has a separate tool of doing this, so it will get exactly the same result. In terms of the correlation, we say, okay, here we have 4 different numerical series, and on the diagonals they're always 1, so not very interesting. What we are really interested is the correlation between wage and education. Just to refresh our memories, correlation is a statistical trick that measures the tendency or the relationship between 2 variables. Usually, it takes values between -1 and 1. The closer to 1, the more positively correlated, we say. It means that when 2 variables, when one is increasing, we expect the others are also increasing. I'm not stating anything causal, just directional result. Right? So we have seen this before. A positive correlation of 0.4 between wage and education is actually good news for all of us because it says, in general, for the observations with longer education in years, they in general will have higher wages. And we also briefly talk about the negative correlation between education and experience, right? The reason is because, for a given person, the longer he or she stays in school, the relatively less years he or she will spend in working. So the coding itself is not that important, but it was the interpretations and understanding of the data that will make a difference. So let's quickly run the code for this visualization part. We're going a bit faster because we've learned majority of them twice already. Once in Excel and also briefly in Python already. So to start with, we can make a box plot for a single data series, and we can feel free to change the setting of whether vertical. So VERT stands for vertical, whether we want the box plot to be vertical or not. So if you change it to true, the box plot will be vertically presented. The shape will be exactly the same. And you can feel free to change the X labels and font sizes. I'm not going into details there. Similar for the histogram, you can change the colors, change the number of beams. Usually we control the number of beams to control how fine we want to segment the X ranges. The more number of beams, the thinner the beams, the thinner the intervals, the more detailed data we have. Right? Feel free to change the numbers and see what will be different. And then here comes the scatter plot. Here, this is the example I say, okay, the alpha parameter actually will help us in visualizing this. Because as you can see here, let's try changing the alpha to the default value. Default alpha value is just 1. Means that our plot is not transparent at all. And let's see the plot. So the plot will look something like this. So I would argue that this plot is not as good, not as informative as our previous one, because this is a scatter plot. Very often we will see the scatters, like the points, stack on top of each other. So in that case, it's not very straightforward for us to see the difference. For example, here, we see a lot of plots are stacked together, but we don't know how many of them, right? So in this case, if you change the value of alpha, it was 0.3, then by default, all the dots are somewhat transparent. Then when they are stacking on top of each other, the color will be darker. So we naturally will understand, actually here within this area, we have more observations. So this is a very good usage of changing the transparency to convey more information in your data visualization process. And finally, let's quickly compute the correlation table. Same as before, we can only compute the correlation values for numerical columns. So we have to specify something like numeric only equal to true. Well, otherwise we would have errors. So this is what we get. It will be a matrix, and you only need to focus on the lower triangle or the upper triangle and making certain interpretations as what we did. So that's roughly about the quick summary of data and in terms of summary statistics and some quick visualization, depending on whether it's a single series or multiple series we were talking about. Then let's briefly talk about handling missing data, because in the previous example, or in the very fundamental examples, we will assume that our data are always complete. Means that we have all the columns, all the rows filled with meaningful input. However, in reality, sometimes, in many cases, the data are messy, empty, and filled with missing values. Let's take a look at this example. The CSV file is called GDP, which measures for 215 countries and regions for their historical GDP values. But as you can imagine, this statistic is not very easy to get. So for some countries and regions, historically, they do not have the observation. We can actually open the data file to take a closer look. gdp.csv. If the data is missing, if you open it in Excel, it's not showing up anything. But once we try loading the CSV file into Python, it will show something like NaN, which is equivalent to missing. For example, for the country of Aruba, it's missing a lot of the GDP observations. We only start collecting the GDP number starting from 1986. So then we are going to teach several useful methods and fill in methods to deal with the missing values. So first, let's try to read the data. First, let's go to the slides, actually. Let me quickly introduce the methods, then we will run the code together. So you can think of this as an exercise. Of course, the more important thing is not for us to learn the new methods. They are relatively straightforward. You can think of the following as several exercises to recap on the data frame related referencing we were talking about. So whenever you load a data file and you see this NaN, it actually means the missing value. So the useful method to detect whether a value is missing is we have a pair of them called is null and not null. The word null actually means empty or nothing. So is null, those are controlling statements. So is null will only return true when the observation is a missing value. And not null will be the opposite. It will only return true when the observation is not a missing value. So let's take a closer look to this example. We have a data frame called GDP, and we use .log. Hopefully you still remember this was the label-based referencing system, right? Log. So whenever you see log, you say, okay, you should call the data frame, the columns by its name. So here, a data frame with 2 dimensions. In the first dimension, we are selecting all the rows by using a colon. In the second dimension, which is the columns, we're only selecting 2 years, 1960 and 1961. So instead, the first half of this code will select all the rows and only the two columns for the data set, which is a subset of only the GDP observation of 1960 and 1961. So after that, we applied the method of is null. As I said, the definition of is null will return true or false. If it's a missing value, it will return true. If it's not a missing value, it will return false. So this will give us an output of two columns and 200 rows and two columns of Boolean statements, true or false. Once we can use is null or not null to detect whether a value is missing, then it can be easier for us to make the selection. This is what we learned right before this lecture, right? We are making, once we have the Boolean statement, we can directly apply them to select subset of rows. So let's take a closer look at what does this line of code do. So again, we are using GDP log, so we need to call by the labels. It's comma to separate the two dimensions, right? Row-wise and column-wise. Row-wise, we say GDP 1960 for that specific column dot null, which will give us a single column of Boolean statements that only be true when the value is not missing, right? So by doing this, we are selecting the subset of the rows that 1960's GDP value is not missing. And then this is the row-wise. We're selecting a subset of rows, row number 1, row number 10, and so on. And what happens to the column? The column, we're not selecting all the columns. We're selecting two columns, which is country name and 1960. So actually, this line of code will help us select the subset, row-wise, select the subset for all the countries and regions with non-missing values of 1960's GDP value. And for the columns, we're selecting the country, region name, and 1960, the year of 1960. Right? So this is by applying what we have learned by using Boolean statements to make the selection of subsets of rows. So we have talked about how to make the detections of the missing values. Then naturally speaking, the next topic would be how do we deal with the missing values? There are two different approaches. Either we drop them, like remove the missing values, or we fill in the missing values. Right, we will teach both. If you still remember, I think in the Excel power query editor, we quickly talk about remove errors or remove duplicates, remove missing values. So here, the logic is similar, but well, of course, the realization is a little different. So the method or the function, actually here is a method, is called drop NA. NA actually means missing value, and drop means that we throw it away. So the drop NA followed by a parenthesis will automatically remove all the rows with any missing values. So take a closer look at this in this example. So for the first row, it contains several missing values, but as well, it contains a not missing value in the year of 1986. But still, we're going to throw it away. So you can think of this default option of drop NA being very, very restrictive. As long as we have a row with at least a single missing value, we are throwing the entire row away. So be cautious when you are doing this because potentially you are compromising or you are sacrificing certain part of your data set's information. Right? If you do not want to be this restrictive, you will not do this exactly, but in the method of drop NA, you can actually specify how restrictive you want to be. You can only choose to drop in the whole row when they are all missing. Right? That's something we can do. Another thing that we need to pay attention to is that the drop NA is not automatically updating the original data set. This is the reason why here, when we write down drop NA, we need to make a new assignment to a new variable. Here we can call it temp, EMP, or whatever. So after drop NA, this new assignment, later we will run the code together. The original data set will not change because, let me repeat. This drop NA method by default will not automatically update the original data set, data frame. It will make the assignments after dropping the NA to the new variable. This is what happens afterwards. This slide is exactly what I was talking about. And don't worry, if you don't get it now, we will try to run the code later together. But over the concepts first. Whenever we have a data frame that contains missing values, like in this case, the data frame is called GDP subset, and we directly apply drop NA, this original data frame will not be automatically updated by dropping the missing values. Instead, if we want to keep the updated data frame, you need to make a new assignment to a new variable. For example, called temp, or whatever other name you prefer. What if you want to directly update the original data frame GDP subset? So we can also do that. We need to add in another argument called in place equal to true. By default, this in place is false, means that whenever we update, we do not automatically update in place, means that on the original data set. But here, if we specify the in place is true, then the assignment does not make any sense. The assignment itself loses its meaning. Instead, this drop NA operation will be conducted on the original data set. Right. And similarly, we can use the second approach, which is called fill NA. That works more or less the same as drop NA, but instead of removing the rows, we're going to, this is like a find and replace. We're going to find all the NA values and replace the NA values by our specified item. For example, instead of NaN, we can manually replace all the missing values using a string of unknown. And of course, instead of using a string of unknown, you can choose to fill in with some other values, like filling in the value of GDP using 0. And you can, similar to the previous method of drop NA, you can feel free to choose to specify whether you want to perform this operation directly on the original data set, which you will need to put in place. Alternatively, if not in place, then you need to make a new assignment. But be careful when you are replacing all the NAs with numerical values like 0, right? Because you may mislead your readers or users of the data set because, for example, here, for the first country, you are replacing the missing values using the value of 0. But it does not mean that for the year of 1981, the country's whole GDP is 0. It's not possible. It just means that, okay, you do not have any information. So when filling the missing values, we need to be extra cautious. But that's less important. Instead, let's run the code together. For some reason, so here. Let's run the code together for this missing data part. Same as before, we start by reading in the files and assign a name of the data frame called GDP. And if we want, we can apply what we just learned, right? GDP heads. It's in the first 10 rows. So we can see the name of the first 10 countries and regions, as well as their GDP observations. We can see many of them are missing, especially in the early years. Right? NaN means missing values. Then this was what we just learned, not just learned, but in the previous lecture. Whenever we are using log, we know we should make the reference by the name. Then this is what happens. Let's break down this line of code piece by piece. Let's forget about this is null. So a closed bracket and 2 dimensions using the reference. Otherwise, in the first dimension, we are selecting all the rows. That's fine. Column-wise, we are selecting the 2 columns, 1960 and 1961. This goes back to a very important difference we say in the previous lecture, right? When we're talking about the 2 referencing systems, we say by using log, we should include the stopping point. That was, if you still remember, a fundamental difference compared to the other referencing system, which was the integer position based. So by checking the 1960 and 1961 being the stopping point using log, so we should choose both 1960 and 1961. So as a result, if we directly run this part of the code, it will show us a subset of all the rows and only those 2 columns. Pay attention, 1961 is being selected or being included. Then we apply the method is null, which will give us the Boolean statement, which is true if the value is missing. So it will give us another data frame, a new data frame of true and false for those 2 columns. And once we know how to construct the Boolean statements like this, we can make selections. This is what we learned in the previous lectures, right? Suppose this is what we're going to do in the next cell. Suppose we use is null or not null to identify whether they are true or false. You can use them directly to select a subset of either the missing values or the non-missing values. So here we can quickly change to not null, which will be exactly the opposite. Those 2 are just symmetric. Right? So let's continue. And same as before, let's try to decompose. Decompose each of the referencing details. This is similar to what we did, right? Let me copy paste this part and see what is the intermediate output. GDP 1960 will select single column of 1960s observation, and not null will give us a sequence of Boolean statements, true or false, right? False, true, true, true means that the first one is a missing value for 1960, right? Then true, 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 right? Basically, it's the Boolean statement of the first column. That is row-wise. We apply this sequence of Boolean statements to the rows. So this will automatically make a selection of all the rows that are true. In other words, we are only trying to select a subset of the countries that have non-missing values of 1960s GDP. So this is what happens row-wise. What happens column-wise is simpler. We're selecting only two columns of country name and 1960. So after combining the rows and the columns, we end up selecting a subset of all the countries that will have non-missing values. You can see the values here, not one missing value, non-missing values of 1960s GDP. And only those two columns. The other columns are irrelevant because we didn't select them. We're making the reference. So this is a combination of exercise, talking about the combining Boolean statements and making a selection using references. And then we are going to show different ways of dealing with missing values. One is drop, the other is fill in. So to do that, let's make a copy of the original data frame. Let's call it GDP subset. So by doing this, so GDP subset is identical, is equivalent to the GDP data frame here. Then let's try. This is what we've shown in the slides, right? Whenever we see drop NA, the original data frame, GDP subset, will not be automatically updated. So we can take a closer look. Instead, we need to make a new assignment. Let's run the code. So after we make the drop NA operation and we assign to a new object called temp, which is the short name for temporary object, temp, then this temp object or this temp data frame will contain all the countries that does not have any missing values. Right, so this is what we have. Actually, only 122 countries in the data set have complete, this is what we call complete observations. Means that from 1960 to 1980 something, no missing values. However, my point is, if we take another look at the original data frame, which is what we call the GDP subset, all the missing values are still there. So this is what we say, okay, the method, by definition, the drop NA will not automatically update or change the original data set. Instead, it will perform the drop NA operation and make the assignment to a new object. So if you directly write down drop NA and do not make the assignment, you are basically doing nothing because it's not being saved. Right? So you make some changes, but you are not saving it. That's the analogy. What if we directly update the original data set? We say, right, in place. We only need to specify the so-called in place equal to true. In that case, the assignment does not make any sense. Instead, the original data set will be directly updated. So this was the original GDP. And if we apply this code, GDP subset drop NA and in place is true, this drop NA operation will be directly performed on the original GDP subset. So this temp will be nothing. So let's quickly check. Right? Because of this in place, it does not make any sense to make a copy and assign it into a new object. So this temp is actually nothing, none. This assignment does not make any sense. And right now, if you take a look at the GDP subset, this will become the updated, the cleaner, complete observations because the in place is true so that we drop NA on the original data frame, which is GDP subset. That's the difference. Depending on actually what you want, whether you want to directly update on the original data frame, means in place. Alternatively, if you want to make a copy and make a new assignment, well, you stick to the default. But remember to make the assignment. Otherwise, you are not basically doing it. And by the way, we say that the square NA is being the most restrictive to throw away any row as long as it has a single missing value. So if you do not want, we are not going into details, but if you do not want to be so restrictive, but only throw away the rows if it's all missing, then we can use the help function to ensure whether it will work. Data frame swap. Yes. So we can always use the help function, or if you do not bother, you can always Google or ask the pilot or something. You can check the documentation. For example, here, default would be any, means that we remove as long as it contains any missing values. You can change it to all. You only remove false when they are all missing values, right? So this will help you control how restrictive you want to be. But again, we're not going into details. If you're interested, feel free to explore. Then let's talk about the other way to deal with the missing values, which is by filling in the values. It's called fill NA. To do that, we go back to our original data set, which is we read the data file again, that's called GDP, and make a copy of GDP subset. The method fill NA is followed by argument that whenever we encounter NA, you find NA and you replace with what? This is we need to specify. You can use a string called unknown. You can use a numerical value called 0. It's up to your decision. Here it's the same. It's exactly the same, depending on whether you want to fill the NA on the original data set. By default, it is not. So after this fill NA, you need to make a new assignment by making a copy of the original data frame and fill the NA. So same as before, you need to assign the new updated fill NA data frame into a new object data frame called temp. And if you take a look at the GDP subset, it was not automatically being updated. So all the missing values are still there. The logic is exactly the same as in the drop NA. It's the same. If you want to fill in the NA by directly updating the original data frame, GDP subset, again, we're going to use in place equal to true. In this example, we're going to fill in all the missing values with a numerical value of 0. But be careful. Sometimes we do not want to give people the impression that, okay, a country whose missing values actually have the GDP of exactly 0. But the message is that by doing this, we do not need any actual assignment, but directly updating the original data frame of GDP subset so that it automatically updates in the original place. That's why we're calling it in place. In place. So this is more or less about the data descriptive part and lecture 9. Before we go to lecture 10, talking about functions, do you have any quick questions? Or dealing with the missing values and before was data visualization and related topics? It's fine. If you have individual questions that you can feel free to talk to me during the break after the lecture and so on. Then let me close this and go to lecture 10, which is supposed to be our last lecture on Python, talking about functions. So we actually do not learn that much, but hopefully you get a sense of how this language is being used. We'll be talking about functions. To start with, I want to give you an additional example of a very, very famous game, one of the most famous games in the gaming history, Super Mario Bros. While this was the childhood memory for many of us, I want to point out a very interesting fact that this game was actually incredibly small. If you think about the size of this game, this Nintendo game released in 1985, the size was only around 32 kilobytes. Which, if you think about it nowadays, if you write down any random document, is as large as this, right? It's very hard to imagine that a visual game like this can be squeezed in that size. So of course, there are many different ways to contribute to this very efficient size of the popular game. I want to point out one particular interesting fact that the reuse of textures. So if you think about it, actually, I played this game many times when I was a kid, but I never noticed this actually. If you pay closer attention, actually the shape of the bushes, the clouds, are the same. So by only changing the color from green to white, of the same shape, actually, it's representing bushes and the cloud at the same time. So this game is successfully using many different things like this. So by reusing of the textures, it avoid, picking up so much memories and stuff. So I want to use this example as a motivated example for us to learn functions, because roughly speaking, one of the main purposes of using functions is to reuse part of the code so that you do not have to write it down manually every time. So if you think about it, we can abstract the use of textures in this game to something like this. Suppose we are writing the gaming code for this game, and we have the code for generating the part of the image. Then we are reusing part of the texture so that depending on the color and the location of the image, we're using the same shape to generate potentially different images. So if the input, we will require certain input. If the color is green and the location is the bottom of the page, then we see, okay, we generate the image of bushes. As comparison, if the color is white and the location is on the top of the screen, then we say we generate using the same shape, the same block of code in the middle, we're generating the image for cloud. Because if you compare the two examples, the code for generating the images are exactly the same. By doing this, we're saving a lot of spaces, we're saving a lot of memories. Essentially, this is the key idea of using so-called function. So far, we should be quite familiar with the word function because we also use many different functions like in Excel. In Python, this is similar, but it's more structured, it's more formally defined. Whenever we're talking about functions, you can think of them as a black box, which typically takes certain inputs and will process the inputs in certain ways that we define and generate certain output. I will give you many examples to help you better understand the concept of functions. So roughly speaking, this is what happens in the logical flow. We have certain inputs. In a real example, the inputs are colors and locations. Means that the inputs should be flexible. Means that we can feel free to choose different kinds of inputs. For example, for color and location, we say the color can be white or green. Location can be top or bottom. Then we have a generic block of code. Think of this as a black box that will help us process the inputs and generate a certain output. In this case, the block of code will be the function main body, and the output will be the resulting image. Then, of course, with potentially different inputs, you will generate different output. And in Python and in many of the programming languages, we call the output, generating the output, we call this return. You can think of this giving certain inputs to the black box. It will do something for us. It will return us the output. More generally speaking, inputs require certain input arguments. We're quite familiar with all of this because even Excel functions will require input arguments. For example, computing the average value, we make the selection of all the numbers. Right? Those are the so-called input arguments. Then the function itself will do certain tasks for us. Like the Excel average function will compute the mathematical average for the value we select. And then it will return us the results. In other words, the output. In the Excel example, it will be the average value. Right? We will start with very fundamental built-in functions in Python, which are the functions that we can directly use without the need of self-defining them, or without the need of relying on any external packages. For example, those are all the functions, the following all the functions or methods we learned so far. For example, the float function. We say, okay, this function we are familiar, it will convert whatever the input to a floating number. Here, if the input is an integer, 2, this float function will help us convert whatever the input to the corresponding floating number as an output. So note that, okay, we start with a very simple example, but hopefully you understand the spirit is that for whatever the function we're going to use, it is flexible enough to take potentially different inputs. So here the integer can be 2, or it can be any other number, right? We can convert to the corresponding, depending on the input, the output will be also different. So this float function will do the task of converting to the floating number, which will return as output. So that's the most fundamental example of using a function. Of course, sometimes the function has a different syntax. We say sometimes we use a dot followed by a special kind of function. Those are called methods. Methods are special functions that usually only apply to a specific data type. For example, we learn strings, right? When we learn strings, we talk about this method called upper, which will convert a string to the uppercase letters. So this is just another example. For whatever the input, which is the method before the dot, right? Input here is ABC. Potentially, we can feel free to put in whatever the input arguments, as long as it's legal, as long as it's strings in this case. Here we use ABC. So this upper method will convert the string into uppercase characters, like uppercase ABC, and return as an output. So this is another example of method, which we can think of methods as special types of functions. Then, to give you some analogy as what we did in Excel, like summation. We're using the method of sum, which will take the input of a NumPy array. Then we can feel free to take whatever array we define. In this case, it's 1 to 3. So the black box or the function body will compute the summation all the individual elements in the NumPy array, and it will return a single output to us. Right? So those are all very similar. We have certain inputs which can be flexible as long as it's consistent with the function requirement. We have a function body that will perform a certain task for us. And after completing the task, the function will return us certain output. And we can make corresponding assignment. Here we call it result, and so on. Those three examples are very easy and fundamental. Now let me show you some other examples that are not very common. Well, we use them a lot, but if you think about the logic of using a function, they are not very common. They're not very usual. For example, we have certain functions that do not have output or do not have return values. So if you think about the function of print, the input in this case is the string that we're trying to print out. The function body, the task the function is doing is to print out the string for us. Once the string is printed out, the job is done. There is actually no values to be returned. So if we want to quickly check the type of the printed, the return value of the print function, actually we're not returning anything. So in the following slides, we can see this kind of special example, right? By using the printing function, what we only need is to print out the message we specify. So making the actual assignment by caring about the return value is not very meaningful. It's not very meaningful, right? So this print function, although we use it a lot, is a special kind of example to show that not all the functions will have proper return values, proper output. So that's a special case. To give you another special case, this is something that we probably didn't mention in detail. Let me introduce a new method of array called append. From the name, you can probably guess what we do, right? We have an existing array, and we want to add in a new element to the end. So this operation is called append. So if we think about this append method from a function point of view, the inputs are two different types of input. The original array, which is before the method append, which is x dot append, and also within the parenthesis, we specify the new element that we are going to include. We are going to connect into this existing array. So we have two inputs. And what the function or what the method will do for us is to add in the new element to the end of the array of x. And that's it. The task is to make the append, but it's not returning anything. Similar to the previous print example, we are not expecting any return value from this execution of the function. So this is another example where when applying a function, we do not have a proper return value. The task is completed within the function body. That's all we need, nothing else. To give you a much trickier example, this is a method that we didn't talk about. This is a method called pop. So instead of adding a new element, this pop method will take out. You can think of this. You can think of an array. It's like a bag of different elements. The method pop will take out a specific element, and what is special about this pop method is that it will do two different things at the same time. Within the function body, it will update or modify the original array by taking away the element we specify. And also it's returning a value, which is the element that we take out. Note that this pop method, within the input, similar to the append, it has two different arguments. The original array, which is x, which is the method before the dot, x dot pop, the index. So here, whenever you see a 2, that's the index. We should take out the element, not the value of the element. So because in Python we start counting from 0, actually we are going to take out the third element. So initially x was 1, 2, 3, 4. By taking out the third element, we end up the x will be 1, 2, and 4. Interestingly, previously we did for append, because the append is once it's done, we do not have any return values. But for this pop exercise, after the operation is done, means that we're taking out number 3 from the array. This number 3 actually will serve as the return value for this function. Right. So this is a very, very interesting case, which is also a special case of doing something on the original array within the function body, but also return some other values. Specifically, this pop method will take out a specific element and use that specific element we take out as the output or the return. Right? So let's take 11 minutes break, come back around 35, and when we come back, we'll run the code together and continue with more for the functions, self-defined functions. In the meantime, if you have questions, come talk to me. Let's resume. Before we start, let me quickly clarify several questions I received during the break. I hope to clarify so that I guess many of you have similar questions. For the group project presentation, for the link submission, you can later, maybe next week or in 2 weeks, I will post the submission window similar to assignment submission on Canvas. So it's a group submission, so you only need to submit once per group. And then you will need to submit the several things like the, I guess there's a report, there's a presentation slides, and the video recording link. The link does not matter what format, whether it's a Zoom recording link, whether it's a Dropbox link, whether it's a YouTube link, as long as you make sure that I can access them, that would be fine. Also, I talked about it before. I received questions about whether it's compulsory to show your faces in the presentation. It's not compulsory, but I encourage you to do so because that's better ways to communicating and to show your facial expressions, gestures, and stuff. So it's not compulsory. If you don't like it, you can choose not to do it. Other questions like the final exam. As you can probably expect, although it will be open book, but no electronic devices will be allowed. So if you want to use iPad or phone during the exam, of course that's not allowed. And also, let me repeat, the internet, the Wi-Fi connection will be blocked during the final exam. So whatever you want to copy paste into the desktop, you need to make sure you finish everything before the starting of the exam. Because during the exam, if let's say me or other invigilators see a thumb drive on your desktop, that will be dangerous, right? So I hope you understand. What other questions do we have? So back to what we just covered, I think it will be helpful to clarify. One question I think is a very, very good question was, why do we care about if a certain function has a return value or not? So the short answer is that it depends on whether if it does not have a return value, then assignment will be meaningless. For example, for the print function, because the print function does not have a return value, if we try making an assignment, print, then making an assignment to a new variable called result. Because it does not have a return value, this assignment is meaningless, so this result will be empty, will be none. Similarly, if we have a function that has an output value, like this pop, the return value is the element that we take out, then the assignment will make a difference, will have certain meanings. If we assign this pop output to a new variable called result, then we have the result value to be 3, which is the element we popped out. So the word pop, actually, you can think of this as, you have a sequence of items, you pop one out so that we take out, so the original series will no longer have the item, but we now have the item on our hand, which is the return value. So that's the word pop. Before we continue, do we have any other questions? I think you can ask me anytime so that I can clarify in front of the whole class so that we don't have any other confusions. Let me think what other questions I may have. Not right now. Also for the format of the final exam, I mentioned several times, and also I promised if we have time in the last lecture, in 2 weeks, if we have time, we will briefly go over the previous year's final exam. It will be a combination of multiple choice questions and the big questions like in Excel. Last year it was. The exam will be 3 hours. So last year I was designing too many questions, so it turns out to be a lot. So I hear people complaining. So this year we will see. Right. If you have any questions, just let me know. And also, as promised, last comment. As promised, let me repeat: the Python related question will only appear in the multiple choice questions. They are easy because sometimes I give you confusion options like all of the above or none of the above. So it's actually quite challenging. Let me think. The previous years, I included 30 multiple choice questions, and the average among the 30 was like 16 to 17. So not very straightforward. Maybe this year will be easier, so don't worry. After all, it's only 30%. So to quickly summarize, typically we can think of decomposing any functions into 3 potential components. Not necessarily all 3 are meaningful. Inputs will consist of arguments, potentially multiple of them. The function body, think of this as a black box. The code will help us perform certain tasks. And then there's an optional return object called output or result. So before defining our own function, let's try to go to the Jupyter notebook and run the code together for the previously covered examples. So we start with the Python built-in functions. As you can see, the built-in functions are automatically defined and referred. So we do not even need to import any packages. So we start with the function float, the method upper, and the sum. Actually, this is not even from the sum. The sum is actually a built-in default basic Python function. We do not even do NumPy. And we can directly apply to a list of elements. So the common things between those 3 fundamental simplicity examples are they have a clear specified output or return value. So because they have return value, it's okay for us to make assignment for the function output to a new object. Here we call them results. So here the results are the return value or return objects. In contrast, some functions do not have return values. For example, the print function. Instead of return something that is useful for us for assignment, the whole purpose of this print function is to complete the printing task within the function body. So it's not returning anything. In other words, the return value would be none. To see this, if we try making the assignment of the print function and to a new object called result, then the result is just a null. Means that, okay, this function does not have any return value output. In most cases, this is less relevant because if you want to understand better of a function, you can just try using it or making the assignment. As long as you see, okay, the output is none, you realize, okay, there's no output, no return value. So we learn by doing in coding, right? Then it was the two special cases. One is append by adding in, right? So we have the initial list of x1 to 3. X.append4 is not returning x, by the way. It's not returning x. The method or the function itself is not returning anything. It will modify or update the value of x. X is part of the input by adding the new element of 4 after that. So if you are trying to, same as before, this is similar to the print function. So if you are trying to make a new assignment, let's say y equal to x append 4, you print x. X is being updated, so x is 1, 2, 3, 4. And print y. And you can see y is nothing. So similar to the print function, because this append method or append function will do the job within the function body and is not returning any objects. So if you try to make a new assignment, it does not make sense. Right? It's meaningless. So below is a special example of a function. We say it's pop that both have meanings for the function of body taking something as well as returning something. So this pop 2, let me remind you again, this 2 is not the value of 2, but actually the index of 2. So this will pop out the third element. So we can try running this. So after this, x and result will be updated. Initially, x was 1, 2, 3, 4. After applying the pop method, x, the third element of x will be taken out. So x will be 1, 2, and 4. And the result will be the return object of this pop method, which is the single element that we take out. So that will be 3. If you want to better understand, you can change it to whatever values, not necessarily 1, 2, 3, 4, right? You can change any random value and change the index as well. Let's try understanding, For example, here we have a different x, and we are popping out. Instead of 1, let me change to some other random values. Here, because 1 represents the index, we are popping out, or we are taking out the second element, which is 99, and the remaining 3 are 5, 102. So this is pretty much about the built-in functions. Sometimes we have valuable, meaningful return objects. Sometimes it's not. Whenever we have a return object, we can make a new assignment to a new variable to make a copy and save it. On the very high level, this is what the function is about. Once knowing the fundamentals, we are ready to define our own function. To illustrate this, let me give you a very familiar example of, going to the Disneyland, or here we call it the zoo. I think this example is Singapore, the nice safari, which I quite like when I was there. So if you still remember, we say, okay, for people with different ages, we are charging different prices for the ticket. If it's baby below 3 years old, it's free of charge. If it's children between 3 to 12, it's 23. Well, if it's older people, the age above 60, we have the price of 16. All the remaining ones, adults, we have the price of 35. So from this example, hopefully you will see the efficiency or the necessity of using a function. Let's take a closer look for this example. Suppose now we are familiar with the rules of setting the prices for the zoo or for the Disneyland. And now we have 4 different people with different ages. Their ages respectively are 11, 36, 37, 67. Without defining a new function, and we are trying to individually determine their prices, you will need to write something like this. You need to write something like this. For the first visitor, we set the age, and we use the if, else function, if, else, if statement we learned before to decide on the prices. And we have another visitor, which is a different age, and we need to run the code again. So if we have 100 visitors, the dumbest way is to copy paste the code 100 times. That's not very efficient, actually. That's not even doable. So here comes the spirit of using a function. As we say, the biggest advantage of using a function is that they are flexible. They are capable of taking in potentially different inputs. In this example, we can design a function called ZooTicket that potentially will take any input ages. Something like this. Potentially, it can take any input ages and compute based on the logic we specify, right? Based on the age groups, the if, else, if statement, and then finally return a value of the ticket price. So generally, let's start by talking about the syntax of defining our own function. So the keyword of defining a new function is called def, which is short for define. And after define means followed by a space, then is the function name. Usually the function name is up to our decision. We can give it names that we like, as long as you can, well, it's consistent with what you understand what the function does. After the function name is followed by a parenthesis. Inside the parentheses are the input arguments required. If you do not require any inputs, you can leave it blank. If you require multiple input arguments, you separate them by comma. Well, this is consistent with what we have learned in Excel. Then the syntax, for the syntax, this first line should end by a colon, to indicate that, okay, we are now defining a new function. So that's the first line of defining a function. Then after that, things are more or less the same. Pay attention, within the function is like a block of code, so that similar to what we have learned when using the control flow statement, within the function, as long as your code belongs to a specific function, you need to use the indent to indicate that, okay, we are now under this function. Remember the structure, the hierarchical structure of the code, right? So specifically about this function requires an input argument called age, which potentially contains different values, this age, right? Any value between 0 to, 80 something, 500. Depending on the value of the age, we are going to tell, based on the value of age, what will be the ticket price. So by doing this, within the function, the code body, we actually rely on two different variables. One is called age, which is actually the input. So naturally, you may have a question of, how come we never properly define this age? If we only have this function here, without calling the function, we never properly define this age. So this is one special thing about functions in Python. Whatever the input argument, we do not need to define it again, because we are going to define it. We never recall it. We never recall the function. We will try to run the code together. So about this age, we do not need to worry about this. So the short answer to that definition of the age input argument is that because it is an input argument to a function, we only need to make the definition, or we only need to specify the value whenever function is called. So you can think of this function as a black box. After we define it, we put it there. It's not being executed automatically. It will be executed only when we call it, only when we say, okay, here comes a new visitor. We need to decide the ticket price for him or her. Then we take the black box, we put in the age of that specific visitor. This black box will go through the body within the function and then give us the output as a return. So this is the logic. So let's take a closer look. Specifically, we're going to run the code together later. Specifically, we have 4 different visitors, right? 4 different ages. For each age, that once we know the age, for example, the first visitor's age is 11, we can call the function by calling the function name ZooTicket, and input value would be that specific age. Here we assign it to age1 or whatever, any other variable. We can call it x, y, whatever we like. Then we put that variable into the argument. Then what happens within the black box is that it will go through this block of code by setting this internal variable age to our input argument. So this is what happens. Age equal to age1 means that we have a new visitor of age 11. This value 11 will be assigned within the function. This is what happens within the black box. Only when dealing with this visitor, by this call of the function, our age will take the value of age1, which will be 11. Then this 11 will go through all the logical expressions, whether it's below 3, no, whether it's below 12, yes. Then our ticket, our variable within the function ticket, will have the value of 23, which will be returned from the function, right? So the output of this zoo ticket, H1, the return value will be 23, which will be further assigned to our ticket 1. So if you think about the whole procedure, it's actually pretty elegant. We have a global environment and we will have a local environment, which is within the function. Later, maybe after half an hour, we'll briefly talk about the local, global environment. But so we have the full procedure of going in, pass around the values, do some certain tasks, and pass out, return the values. So let me repeat the process. Globally, we would have an H1, or call it whatever you want, H1, which takes a specific value of 11, 36, 37. We pass this specific value into that function. So within the function, it will be repeatedly used by assigning the value from the input argument to the age variable. You can think of this as a generic local variable of age that can completely take different values for different calls. Within this call, the age is 11. So according to the specific value of 11, it will go through the logical expressions and determine the local value of the variable ticket, which will be returned. Because it's returned, we can make the assignment to whatever function or to whatever variable is global, for example, ticket 1. We can repeat this process as many times as we want for different inputs. If the age is 11, we can do it. If the age is 36, 37, 67, we can always do the same. The only difference is that by using different input arguments, following the same logical expression, the output will also be different. So that's the spirit of applying a function. This will save us a lot of time and effort compared to manually writing down the code multiple times. Right. So it is worth mentioning that whenever we see a return inside a function, the function will stop there. So in other words, the value should only be returned once. If you see multiple returns, only one of them will take effect. So this is the one version of this ticket price function we define. We assign a new variable. We define a new variable called ticket, and depending on the value, different value of ages, we assign different values for the ticket, and eventually return the value of ticket. So this is very common, very beginner friendly. And of course, there's a different way, an equivalent way to write down this function. Let's take a new look of this. So we can define another function which is essentially equivalent to our first function called zoom_ticket_new, which also takes in a single input argument of age. So here, instead of using multiple if, else statements, we can directly, without the need of defining the actual variable called ticket, we can directly choose to return. Because we said it before, pay attention to this note, a function will terminate whenever it triggers a return. So in other words, whenever we execute a value to be returned, all the remaining code we can ignore all the remaining code because we can only have at most one return value at one time, usually. So this code, hopefully you can understand what it does, is exactly the same. Based on the input value of age, if age is less than 3, we directly return 0. Without the actual step of defining ticket and eventually return ticket. Because if we return 0 here, all the remainings will not be executed at all. So if the age is not below 3, means that if our visitor is not a baby, the first if will not even be triggered, so the return 0 will not be executed. Then we proceed with other if statements. So eventually, one of the 4 returns will be triggered, and that will be our return value. We can do this only because in Python, return arguments will only be triggered once within a single call of a function. Right? For any visitors whose age are between 3 to 12, their ticket price will be returned exactly here, $23. And all the remaining will not be executed. Because once returned, you can think of this as a break of the function. Right? Once it's returned, the current call of the function will be terminated. Similar for the adults, their return price will be 35. And if all the 3 if statements are not true, means that our visitor is not below the age of 60, then we know they are elderly, they are old people. Then we directly return the price of 16. So this is a slight different way of writing down the same function, which is a little bit trickier to understand, but you do not need to write in this way, but hopefully you understand what happens within the function. This function is exactly the same as the function as the zoom_ticket. They do exactly the same job. A little bit about the coding style. Again, whenever we see a yellow color text box and a coding style, it's not compulsory, but it's highly recommended. At the beginning, right below the function name, the line of code that we define the function name, typically we will use the triple quotation mark to talk about certain comments about what the function does. This will be extremely helpful whenever you are trying to show the code to some other colleagues, or potentially to your boss or to your future self, so that you get a sense of what the function does. So this is good documentation. And a quick comment about the difference between the triple quotation mark and the hashtag. These are comments. The triple quotation mark will allow you to write comments across different lines. So you can think of this as the major difference. So you can either use a comment or use this block string, formally speaking. Feel free to use whatever you want. And of course, because this is just the coding style, it's optional. If you really do not want to write any comments, that's also fine. Quick summary of why we prefer using functions in many cases. Biggest advantage is to reuse the code so that we do not need to write down new codes anytime. It's easy to test and debug because by writing down different functions, your code will become highly modular. And by checking different functions' performance, it's easier for you to understand and debug the code. So high readability. Then let me give you another example. This is not the exact example of this course. But many other courses in CPU, I think we will use the similar logic. Well, the courses, usually a course will contain 2 components, continuous assessment, we call CA, and exam. Depending on how much the exam take part, I mean, for our course, the exam is only 30%, but many other courses, maybe 50%, like in this case. Then a student's total mark will be computed using continuous assessment plus exam plus multiplied by 0.5. Then, in this case only, I'll have to make this clear. This is not what happens within our course, but in this case only, a total mark greater than 80% will be A, 70 to 80 will be B, and 60 to 70 will be C, and below 60 will be D. So this example is very similar, but the only new thing that we learn is that potentially we can have multiple inputs and multiple outputs. Here we return two values, it's the total mark and the grade, the letter grade. Whenever we are returning multiple objects, we need to separate them by commas. So naturally, we want to ask, what is the object type that we're returning? It turns out to be a tuple. A tuple is like a pair or a longer, if it's more than 2 units, a sequence of items that we can decompose or unpack them. So later, when we are trying to call the function, we can either directly assign it, because when making the assignment, we have two objects. We are returning two things. One is the total mark, a numerical value. The other is a letter grade. So we can either combine them and assign it to a new tuple, or alternatively, we can, when calling the function, we can directly make the individual assignment by using a comma to separate the tuple. Right? So let's quickly run the code together. Of the two examples, one for the zoo ticket, the other for the computing the marks. For the zoo ticket, this is the first function we define. Pay attention to the syntax. Start by def. Let me zoom in a little bit. Start by def, followed after the space, followed by the function name. So the function name should change its color to blue. And then the parentheses within the parentheses are the input arguments. Don't forget the colon. Don't forget the colon, because in different languages, later some of you may be learning R. In R, it's different syntax. So here is in Python we use colons. And then it was the logical expression, but pay attention to the indent. All the code block within the specific function needs to have certain indents to tell us that up to return, to tell us that they belong to this specific function. So when you run the code, here we define a new function called zoomTicket. When we run this function, we do not have any output. We're just making a definition of the function. We have not called it yet. So this will not give us any return. To see this, if I check age, not defined. If I check ticket, not defined. Because again, let me tell you, I'm talking about this age, here, age and ticket. We say, okay, ticket 0 or 23. No, we have not called the function yet. So if you try, and also those variables are local. So only happens, this assignment's age, ticket, is only meaningful within the function. Later we'll talk about the local and global spaces, scopes. So we have not called the function yet. So we have not applied this function yet. It's only useful whenever we call it after the definition of zoomTicket. We need to call it somewhere whenever we need to use it. As in this example called zoomTicket age. Here, you can make whatever assignment. For example, you can directly put a zoomTicket of 11, like a specific value. What happens, let me repeat, is that Python will call the function by assigning this input argument's value, which is 11, passed to this age variable locally, and the age will have the value of 11. You can try. You can actually better understand by sometimes printing out the values. Let's say print out age. Then every time we call the function, before we even go through the function body, we print out the value of age. So let me go back. Name age is not defined. So here is age 1, because age is not defined in the global measure. It's only meaningful within the function. So age 1 is 11. And within the function, every time we call the function, it will first call the value of age. Age will be, the value of 11 in the first case will be passed to this local variable called age, and go through all the logical expressions and return us the ticket value. Here is ticket 1, 2, 3, 4. Right. Similar before, because we learned that within the function, it will only be returned once. So instead of defining the actual variable called ticket and return ticket in the end, we can choose to directly return the values within each if statement. Here, whether you are using else if or if, they're equivalent because they are mutually exclusive and only one of them will be true. In the end, if all of the previous ones are not true, we have only one option to assign the order ticket price. So we can rerun the code and it will give us exactly the same output. Now let's take a quick look at this computation of the final marks. It will take two input arguments. Whenever we have multiple input arguments similar to Excel, we are going to separate them by commas. The two arguments are say A, continuous assessment, and exam. And we are going to compute. They are supposed to be numerical, and we are going to compute to use this formula. And based on the value of the total mark, we will assign the grade. And here, the special thing about this function is that it's returning a tuple, is that it's returning a group of multiple objects at the same time. The total mark as well as the grade. And potentially, they can even share different data types. Total mark here is numerical, it's floating number. The grade here is string. Right. So let's run the function by defining it, not calling it yet. Then we can try. For example, let me quickly, you do not have to follow me on this. For example, if we call the function and assign the output to a result, we can quickly check the type of the result, because the result will contain both the total mark and the grade. It should be a tuple. Tuple is an object that is, you can think of a sequence of potentially different objects. Instead of making a single assignment, you can directly unpack when calling the function name. Means that whenever we have two different outputs, two return values, you can assign them to correspondingly to two different objects, like total 1 and grade 1. Total 1 will be corresponding to the total mark, and grade 1 will be corresponding to the grade within that call of the function. And once you have unpacked the tuple from the return objects, then you can deal with them individually, like convert to strings and print out in a sentence. So for example, the first student, CA is 40, final exam 85, then we can compute the final mark as well as the letter grade. So this is what we can do. The only different thing here is that when you are returning a tuple, means that when you are returning multiple objects, you can choose directly assigning them to multiple objects. Python will allow this. This actually turns out to be very, very convenient. Right? So let's do a quick summary and continue by talking about something trickier, the scopes. So a quick summary of what we need to pay attention when defining our own function. First is the keyword def define, followed by a space and function name, and parentheses, input arguments, followed by a colon. That's a fixed syntax requirement. For the code body, which is the task that this function is doing, we need to make sure that the indent is specified correctly. And whenever you need, you should specify returns. As we say, not all functions are compulsory to have any returns, but usually, typically, we expect something to be returned. Typically, not always. Now let's talk about something about scopes. Because previously we tried, right? The variable age and ticket, they make sense within the function. But if we try to call the value outside of the function, we get an error saying it's not defined. Why? Because certain names, certain variables are only useful or only making sense within the scope of the environment. So you can think of this as, I'm not sure if you still remember this, back in Excel, when we are giving certain cells names, we need to specify scopes. We have a space name manager. Some names will apply to the whole workbook, while some names only apply to a specific spreadsheet. So here is similar. In Python, the scope rule or the naming rule follows a rule called LGB, which is in order, local, global, and built-in. Within this course, we are going to focus on the difference between local and global, while built-in is kind of a special case. Specifically, LGB is actually the order that Python will look up when we are trying to make a reference of a variable name. Starting from local, if it cannot find anything local, it will find for global. If it cannot find anything global, it will try to find the built-in. And if that's not even there, then that's an error. We will try to illustrate the differences between local and global using a very tricky example. Let's define a function called LGB test, which takes an argument called z. So let's take a closer look slowly about this example. What do we mean by local? Local actually means that the environment is restricted to within the function only. Global means that outside functions in the Jupyter Notebook global environment. And built-in, which usually are referred to the functions that the names are pre-specified by Python. And we will not spend much details on this measure, on this scope. So let's take a closer look at this function. This test function, will take a single input argument and give it a value, give it a name or the variable name called z. And within the function, we are making a new variable definition x called local x. And what the function does, this function is kind of special because it serves the purpose of only printing stuff. So this function does not return any value. Instead, it will print the value of x, y, and z. And before printing x, y, and z, it will tell us that we are inside the function. Whenever we are inside a function, we call this a local environment. Whenever we are outside a function, whenever we are not inside any specific functions, we are called at a global. Inside and outside, local and global. So let's try to run the code together before we go through the slides to summarize what happens. Because this exercise is potentially tricky and confusing, so that it's better that we run to see what happens. So this is the function. Two things to notice. One thing is that the input argument, we give it a name of z. So whatever passed in as the input argument will be assigned locally to the value of z. So this is one thing we need to pay attention. The other thing is that locally within the function, we're making the assignment of x equal to string local x. Then we try to print out the value of x, y, and z. So let's run the function. Let's define the function without running it, without calling it. Then something interesting will happen. So here, let me put everything in order. X, y, and z. Outside the function means we are no longer within the function. So we call this a global environment. Globally, we also define x, y, and z to be global x, global y, and global z. We also try to print the value of global x, y, and z. And then after printing out global x, y, z, we call the function. Before running the code, let's try to guess what will happen. Zoom out a little bit. Let's first run the print x, y, z outside without calling the function. Things should be straightforward. Because we define the global value, the so-called global value of x, y, and z, x will be global x, y will be global y, z will be global z. So if we print out their corresponding values, of course, those are the global values. The interesting thing or the tricky thing happens when we try to call the function. We call the function by using the input argument of x. Here comes the tricky part. Input argument is x. So let's think about what happens within the function. The function takes the input argument and assigns to z. So actually what happens within the function is something like this. Go back, something like this. So what's the value of the current x that will pass to the function? X equal to global x, right? Globally, this is globally outside of the function. So essentially we're doing something like this. We are passing the string of global x to the function. So global x. So z will equal to global x, something like this. I'm trying to investigate what happens. So this is what actually happens. We pass the input argument to the local variable of z, and then we try to print out the local variables. So when we print out the local variables, the x, because of the LGB rule, it will first try to search for the local value of x before searching for the global one. So it will print local x. Y inside. Y is not defined in the local environment, so it will give us the global y. And z, currently taking the value of global x, so it will print global x. So it will print something like this. So this is what actually happens. So let me return to the original state. This was the original function. And this was the original call of the function, LGB s of x. So let's try running this and see what our analysis, whether it was correct, right? Right. So globally, when printing out x, y, and z, they are the global x and y, z. So we know that, right? What is interesting is what happens in the local environment when we call the function name and assign the x. What's the value of x? Globally, this is outside the function. So what's the value of x? It is global x. So we are assigning this string global x to the local variable of z. So the local variable of z inside should be global x. So this is the tricky part. This is the tricky part. So local x, global y, and global x. So you're a little bit confused. Okay, you don't know what is what. Let's go through this again by visualizing using the slides. Remember, according to the LGB rule, we start by searching, locally speaking, we start by searching the local name. If the local name is not defined, we search for global name. If global name is not defined, we search for the built-in name, which we do not cover here. Well, that's not very common. So whenever we are trying to print out the x, y, z values outside, everything is normal because we are in a global environment. There's no even local references required. However, so this is what happens, right? For the global name x, y, z, we make direct references because this is not even local. We refer to their global names, global y, x, y, z. So this is understandable. Now things are getting more interesting because we are calling the local environment by calling the function LGB test by putting the value of into that function and assign it to the local variable of z. So the tricky part here is that globally, the value of x is global x. So essentially, we are assigning global x to the local value of z, right? As highlighted here in the slides. So global x is assigned to the local value of z, so that whenever we are trying to print out the value of z according to the LGB rule, we are printing out the local version of z first. Now z has two values. Locally is global. Locally is global z. We take local as a priority. Local is not global, so we print out the z value to be global x. So this is what we see here. Similarly for x, x also have two pair of different values. Locally, x has the value of local x. Globally, x has the value of local x. As a higher priority, so we print out local x. What happens to y? Y has no local definition. So if we try searching for the local definition of y, we find nothing. So we have to go to the global name, which will give us global y. So y will be printed as global y. Right? So this is what happens in this tricky example. So what we learn, other than trying to understand the local and global environment, what is our takeaway from this exercise? Actually, if there's only one takeaway, I would recommend to avoid using the same set of names locally and globally. The best practice to avoid any potential confusion like this is to use different set of names. Within the function, locally, you use simple names like x, y, z. Globally, outside of the function, you use other names like x1, y1, z1. If you totally separate the set of names globally and locally, we do not have this kind of concern to search locally and globally and potentially causing confusions. Now you may be curious, what are the built-in names? Right, we do not cover any details for this third priority. Right, if we cannot find any global names, we print out the built-in names. Well, actually, print function is an example of a built-in name. It cannot find anything, so it will just print out. We're not going to go into details for the built-in function. Some of the names are pre-specified in Python. So even when we give it local or global definitions, without giving any local and global definitions, they may still have certain meanings. So the recommendation here is certain names you should avoid. If you expect the name to be very useful in Python, you should avoid using them. So for example, when you define a new variable, you should avoid, in general, you should avoid calling your variable print, because the print itself, it means something in Python. So maybe you should call it print1 or print2, print x, instead of the original print name. Right? So through this exercise, hopefully you can distinguish the different environments between local and global environments. And you know the priority of making a reference from local to global to building. Right? Then let's use the remaining around 10 minutes to get a start with the arguments, function arguments. We'll probably come back and revisit this exercise because this is very important, and this is not as tricky as the previous example, but very, very important in real applications. There are two different types of arguments. One is called position argument, which is as an example here. So to quickly introduce this example, it's only making sense when we have multiple inputs. In the previous example, we have, in many of the previous examples, we only have a single input argument. So in that case, it doesn't matter. If we only have a single argument, we just put it there. When we have multiple arguments, especially when we have more than 3 input arguments, how to arrange them will become a challenge. Because naturally, you would think, okay, let's arrange them in order. For example, in this case, we define a function which takes 5 different arguments: name, age, gender, faculty, and year. We will use those 5 pieces of information, 5 pieces of input arguments to consist of to form a dictionary to summarize a new student's information. Again, we did not spend much of the time talking about the details of this dictionary, but think of this as a new data type that we can use to do some lookup. So to give you an example of the usage of this function, it's an example of a function taking multiple input arguments, here 5, right? So the default way by using positional arguments is to put the multiple 5 different arguments in that specific order. For example, if we have a new student whose name is Jane Doe, whose age is 20, gender is F, faculty is business, and the year is 2017, then by calling the function name followed in the parentheses, we are going to put the 5 input arguments in that specific order: name, age, gender, faculty, and year. By doing this, Python will know which is which, right? So the first argument, it corresponds to name, the second corresponds to age, and so on. So this is one common practice whenever you have multiple arguments. And by default, you should do this. You should do this. However, Python will allow us to use a different input argument system. Instead of positional, means that, okay, the first one is name, the second one is age, and so on. Sometimes Python will allow the flexibility using the keyword arguments, like in this example. If you understand this example, you understand the challenge here. So by using the keyword arguments, potentially you can shuffle the order of the input arguments. Instead of following the strict order of name, age, gender, faculty, year, you can shuffle them around as long as you specify the correct keywords. Let's see this example. Still, the first 2 are in the correct order. Name is Jane Doe, age is 20, but the last 3 are in different order. Instead of gender, faculty, year, you can actually rearrange the order in different orders, whatever order you want: year, faculty, and gender, as long as you specify the keywords. Let me repeat. Now we have 2 systems. One is positional arguments, where you do not need to use keywords. You directly put in the input arguments, but you need to make sure that the sequence is consistent with the definition of the function. Alternatively, if you do not wish to strictly follow the sequence, you can also use the keywords. But here's one thing you need to pay special attention to. I will repeat this at least 2 to 3 times because this is very important. All positional arguments must be specified before keywords arguments. Example would be this exercise. The green ones are positional arguments, and the red ones are keywords arguments. The only thing that we need to make sure is that all positional arguments should appear before the keywords argument. This is actually very intuitive and very understandable. Why? Because suppose you have certain positional arguments that appear after the keyword arguments. For example, you can imagine in this example, either name or age, without any keywords, appear after the red argument. Then Python will be very confused because once you specify the keyword, you can shuffle the order by not strictly following the sequence. And then if you switch back to positional argument, Python will not know which keyword you're talking about. So that's why we have to strictly follow this rule by setting all the positional arguments before the keyword argument. Right? If you set this, you will have an error. You will have an error. And here's another coding style requirement, not requirement, but suggestions. Usually we do not use spaces when specifying the input arguments. Of course, it's optional, but well, we should try following it. It will make our code more compact and easier to read. So we are now at around slide 61. Let's try ending here because the remaining is a much bigger exercise. We will come back and revisit the same exercise starting from here. Starting from the note here that all positional arguments must be specified before keywords. And we will try to run the code together next time. So after we finish everything remaining in lecture number 10, we will probably spend some time talking about AI and related topics before we cover the previous year's exam. If you have any questions, come talk to me right now or send me an email.